Hi everyone, what's up? Today I want to solve a really nice integral with you. Today we're going to compute this following definite integral. So we're going to have the definite integral from -2 all the way up to 2 of the function x squared times cosine of x cubed divided by 8, okay? And of course we have dx here, okay? So this is going to be the definite integral that we're going to compute today, okay? And this is going to be very easy. We're going to use substitution and change of variable, basically. And yeah, so let's see how we can do it. So I think right off the bat, you can see that if you differentiate x cubed, you're going to get 3x squared. And over here, we have x squared. So I think it's pretty safe to say that a really good substitution for this integrand would be to let u, I'm going to use u as my variable, we can let u be equal to x cubed divided by 8, okay? So let's see how that would go. So I'm gonna, once again, let u be equal to x cubed divided by 8. Now, so that we can, substitute dx, well, we need to compute the differential of u, and that is going to be very simple. We know that du is going to be equal to u prime. Now u prime is going to be equal to 3x squared divided by 8 dx. And now let's see the expression that we have in the integrand is going to be x squared times dx. Okay, so let me isolate x squared dx and see what we get. So you can move 8 to the other side of the equation and divide by 3. And you're going to get the following. You're going to get that 8 du divided by 3 is going to be equal to x squared dx. Okay, so this is, all the information that we need to make a really nice substitution. So let's see how we can use this. So we know x squared dx is going to give us a coefficient of 8 divided by 3. So I'm going to write a new integral with a coefficient in front of 8 divided by 3 because, well, you can just simply move 8 divided by 3 to the front to the front of the integral sign, okay? And now, well, we can write once again the integral sign. Now let's see what happens with the lower bound and the upper bound, okay? Remember, since we changed the variable we're integrating with respect to, in this case we're integrating with respect to u, well, we gotta change the bounds, okay? Because, well, basically over here we're finding the area under this graph, and the function that we're gonna get once we substitute, once we rewrite this function in terms of u, is gonna be a totally different function. And if you use the same interval to evaluate the area under that graph, well, that's gonna be totally different as the area under this curve. And the only way in which we can adjust both sides of this equation to get the same areas is by changing the bounds of integration, okay? That is also, some insights into why we gotta change the bounds of integration, okay? So now let's see. So the lower bound, we know is going to be the substitution that we use, u evaluated at -2. And we know u evaluated at -2 is going to be, so we're gonna have a negative sign in front coming out of this x cubed, and we're gonna have 2 cubed, so that is gonna be 8, okay? And we have divided by 8, so this is going to be -1, okay? So yeah, that's nice. So now let's see the upper bound. So the upper bound is going to be u evaluated at 2. 2 is the upper bound, and and this is going to be, of course, 2 to the third power. It's going to be equal to 8 divided by 8. That's going to be 1. Okay, nice. And so that means that the lower bound that we get is going to be -1, and the upper bound is going to be 1, okay? And now let's write the integrand. So x squared times dx is going to be 8 divided by 3 in front, then du, so we can just write du. And we have cosine of u, okay? Because u was the substitution that we used. So we're going to have cosine of u du, okay? Remember, we already, x squared dx is equal to this expression, and 8 divided by 3 is already multiplying the entire definite integral, okay? So now, yeah, we can just simply find find a value for this. So this is going to be 8 divided by 3, and I'm gonna write it like this. So this is going to be times sine of u, and we're going to evaluate this expression at u equals -1 and at u equals 1, okay? So this is what we're gonna get, and now let's see what this is going to be equal to. So in this case, it would have been really, really nice if we had, if we had some pi some pi coefficients or some expression in terms of pi for the upper and lower bounds of integration, because now, well, we're going to get something pretty interesting, because over here, well, u is going to be in radians, and I don't think I know the value of sine of 1 radian. I probably should, but honestly, I don't know, so yeah. So I'm just going to have to write that number. So this is just going to be the same as a divided by 3 times sine evaluated at 1 minus sine evaluated at -1, okay? So yeah, this is going to be what you get. This has been, the entire problem. That has been the results. And I hope that you enjoyed this video. Hopefully you learned something. And see you in the following one. Bye.